let other people catch up. Thanks for sticking around after lunch. I think we had a full house signed up, but looks like I think a lot of people took a shorter day. But I think we're suffering also because we're at the end of the hall, so everybody's hitting the other rooms first. There we go, some more people. Okay, so I'm going to talk about SDN, software-defined networking, and I know it's a technology that has been hyped for a long time. I mean, it's an acronym that you guys all probably know, but I think I'd like to kind of walk you through the market trends and the vision and business drivers as to why SDN is now really taking on a life of its own, and also tie it to what it enables, right? So I know a lot of us have also been evaluating cloud, right, which is the other big hyped industry trend as well. So there's definitely a strong tie between the two technologies, and I'll go through that as also. I've got a book. So I was an electrical engineer in college, and I've always been averse to reading, or not very good at the English side of things. So for me, I lived on Cliff Notes and books like this. So so anyways, we've got a book out called SDN for Dummies, and it's actually a very good high-level introduction to the strategic vision around it, the business outcomes it drives, as well as dives into the technologies as well. So originally I thought I wasn't going to have enough books for everybody, but I might. So anyways, I will be asking questions through on out to keep everybody interested, and I'll try to hand out these for people that answer them, and we'll try to keep this interactive as we go along. Okay, the other thing, I didn't introduce myself. My name's Herman Chao. I'm the Systems Engineering Manager for the State of California government here locally, working for Cisco. So we have a team dedicated to the State of California government. So I am, what's very near and dear to my heart is the modernization of government IT, and the modernization of IT to really keep us competitive over the long haul versus commercial enterprise offerings and now cloud offerings today. Okay, so I'll start this off with talking about some of the needs and trends that we've certainly researched at Cisco and what we're seeing in the industry as to why the time to act with SDN is definitely now. First is just the evolution of networking itself. So this is a very fancy marketing slide, and there's certainly a lot of nice buzzwords, but not to date myself, the network has come a tremendous way, right? So I remember, when I was going to college, it was really just an email type thing, right? So there wasn't much usage beyond that. I remember then getting out of college, and I had a role where I was traveling quite a bit, and 56K was fast, right? So it was like you wanted to find a hotel where you could get 56K, right? Then you'd get there, and then PowerPoint came along, and you were praying that nobody sent you a 20 meg PowerPoint presentation because you'd be done for the night. I mean, it was literally you started it up, waited for the PowerPoint to download, and you wake up the next day. So to see where we've come from there, right, to T1 lines, to now getting 40, 50 meg down in your home, the internet's come up a long, long way, and what we're seeing is the use of the internet in a lot of various applications. So, first and foremost, that voice now today is primarily run on your IP network. Video surveillance today is even now primarily run on your IP network, right? So it's no longer on closed circuit television. So just a tremendous amount of applications keep filling up the pipes as we keep building reliability and speed within the infrastructure of the network. The one that's, I think, really fascinating to me is, the internet is now really an extension of your intelligence as well, right? So one thing that's fascinating I find with my kids is a lot of what they know and their ability to search the right way actually helps augment their learning, right? Not only helps augment them, but makes them appear a lot smarter than they really are, right? So I've got a guy on my team that seems to know everything, right? I mean, and Cisco has a very wide portfolio of products, and a lot of what he gets is right off the internet, and it's just being able to search for the right things at the right time. So just out of curiosity, just to walk us down memory lane on the networking side, how fast is a T1 line?
1.5 megabits per second.
1.44.
1.5. I heard 1.5 back there. Since he was first, that's close enough. He missed the 044 part of it, so I'll give you one of these if you pass that back. And then, who has the highest? So I live out in the sticks in Loomis, So I get 6 megabits down and 2 meg up, which compared to a 56K line is fast, but I'm hearing outrageous speeds that you can get at home these days. So just curious, who has the fastest download and upload speed?
I get 50 megs.
50 meg down?
Down.
Okay.
150.
150, who, from who?
Comcast.
Wow. Any other? What's your upload speed? Just curious.
About, I think it's 25, 50 or something.
25? Okay, great. You want to move? I got to move to your area. Take this off. Okay. Okay, other big trend that we're certainly seeing, and if for those of you that were at the keynote, was this notion of the Internet of Everything, right? So as the Internet becomes more and more reliable, more ubiquitous, continue to scale to more and more people, the whole notion is, traditional devices that we think of that are connected to the Internet, like the PC, become different types of things, whether it's phones, whether it's, and it's very interesting within the state, if I can get this to go forward, you have parking meters now on IP. I know Caltrans has sprinkler systems on IP, and they monitor the watering of their roadways via IP. HVA systems for corrections are on IP. Video surveillance, as I talked about before, on IP. One very interesting use within the state is cows are on IP. Right, so basically through the use of RFID, they're able to track cows and capture very valuable information about cows to help the beef industry of California. So just a tremendous amount of information and things are getting connected up onto the IP network. The other one that's very interesting that I heard in the keynote today is pacifiers for babies on IP. And my kids are a little older. My youngest one is 5. And as I thought about it, that would have been actually fairly useful. You could measure the temperature of your kid or monitor it remotely. You could always find them because that binky for my daughter was constantly in her mouth, right? So you know exactly where she is because you could track IP throughout your house, right? So those are, I think, more and more of these types of applications will emerge over time. But the ubiquity and the bandwidth that you can get out of IP today in the internet has, I think, driven one of the biggest changes that is hitting us from a corporate perspective, and that's the notion of cloud. Basically taking your whole entire data center and actually moving it off-site, actually running it over the public internet and going to a mega service provider for all your data center needs. And I don't know if you guys caught it in the keynote, PK actually said, if you're considering running your own data center still, you're crazy. I don't know, did anybody hear that? I thought that was a very fascinating comment, right? So for me, and from the research we've seen, I actually don't believe that. I don't believe that's true, right? And the reason being is I really think there's a balance of having a private cloud and a public cloud because there are advantages to both, right? So in my mind, I don't think we're going to end up in a world where there's just 5 data centers worldwide. There's always going to be both, right? And there'll be a balance where some applications are appropriate for one and others are appropriate for the other. And it's balancing the need of control, security, having your data with you, having dedicated performance and measurable performance with the economies, the speed to deploy and scale, right? And ultimately, I believe these are going to coexist. I'm going to talk about a lot of the standards activity that's happening not only around SDN, but cloud, that is allowing for the mobility of applications seamlessly from mega service providers to private data centers and vice versa, so that this notion of supporting a hybrid model where IT becomes the broker, not just a policy bearer or the one that's passing paper between someone that wants to buy public cloud services, but actually one that can host the application and determine when and how to move it between various clouds that are out there in the industry. To share some of that data, we've been doing a lot of research at Cisco around this notion of a hybrid cloud, right? And first and foremost, public cloud is happening. Whether you're seeing it directly from an IT department or not, cloud can be purchased on a credit card now, right? So it might not even be crossing your desk, and the usage might not even be visible from an IT perspective. So it's very interesting. This was done with private enterprises, a study group of over 400 people. And as you can see, in almost every instance, people were using cloud. And over half of them were looking at ways to actually integrate their own private data center with cloud infrastructures that are already out there. Another data point of how cloud is so prevalent, Amazon is trading now over $400. Is that $432? I used to invest a lot in individual stocks, so I keep an eye on some of these. The interesting thing is it was well under 300, probably jumped 60 points 2 months ago, their last quarterly earnings. So that jump wasn't because they're now streaming video and selling media content with prime infrastructure, right? It wasn't because there was some new whiz-bang book that came out. It's because they disclosed their financials for the cloud, and people were shocked. I mean, for them, it's already a multi-billion-dollar industry, and analysts had no idea that they were driving that much revenue from it. So cloud is definitely here today. We need to understand it, embrace it, and see how we can integrate it within the IT infrastructure of public sector. Okay, here's another kind of data point. I thought it was very interesting to see that ultimately there is a place for IT in terms of being that front, that broker of that service, not just by setting policy, but actually providing a portal, actually providing the onboarding of applications. Maybe it's through their private data center first, and maybe it'll burst out to a cloud. But there's clearly technologies and standards and open source now that I think will make this reality in a hurry. And you can see there's a lot of interest as we talk across IT departments in the industry. And what this does is drives an ability to really optimize ROI of a data center, right? So what this shows is, 3 different models. I mean, as you guys look at your data center needs, there's certainly those tried and true fixed applications that are always there that continue to scale. So email, ERP, customer service type databases. So those are perfect for kind of private only or fixed asset clouds, right? But then in a lot of your data centers, you might have multiple tenants that have applications that come and go, or a development group that's doing custom test dev application development. Those may be more appropriate for, say, a public cloud, right? Or something that can support short-term usage and burstable resource, but then it might come down later, right? So if you actually do the math on it, if you do the right combination of this usage, right, you can actually arrive at a model where you can save significant dollars. Okay. Okay, so it's one thing to talk about this utopia of moving applications that have complex security models, complex network models, complex storage models all over the place onto the internet and then back onto our data center and so on and so forth. The reality is, to be a player in this model and to make this a reality, we really have to look in the mirror as traditional networking people and really be honest with ourselves. Not even just networking, server and storage as well. Are we really cheaper, faster, and more secure than what people can offer on the cloud itself, right? We don't just want to be gatekeepers. We really want to deliver a service that's better, faster, and more secure, so that this hybrid cloud becomes a reality that our IT is viewed as an asset and a differentiator. And the reality of networking is, if you look at it, although speeds and feeds have changed and evolved over time, it's still a very manual process. The administration of a network is pretty much the same as it was invented 15 or maybe 20 years ago, right? So the notion of IP addressing is the same. Subnetting is the same. Carving out VLANs is the same, right? Doing ACLs are still the same, done on CLI on each and every device, right? So, when you add an application onto a data center, it's a very involved effort, right? You've got to talk to Bob or Joe or Jim, right, who's got ACLs on a spreadsheet, and then someone else on an Excel spreadsheet is tracking the subnets and IP addresses of different groups and organizations, right? It's a very manual and intensive process. As a result, right, it provides a very slow time to deployment, right, compared to a lot of the newer models today, right, and a lot of the cloud infrastructure today. It creates a lot of manual process and single points of failure. I've been in a lot of situations where you're either debugging a crisis or you need a change to, say, the IPS or a service for security, and that person happens to be on vacation, and that guy's the only one that knows how to configure that device, right? I think we've all been there, right? So organizational silos, right? We're still organized as the networking team, the server team, and the storage team. The notion of throwing things over the wall to get things done is a pretty common practice, especially now with virtualization or server virtualization. It's like, okay, I'm on the network team, they're doing server virtualization, they've got a virtual switch in there with virtual ports. Hey, I'm just going to give you a 10 gig NIC, don't tell me what else goes on, right? Broken security models, right? Inability to debug that type of a situation continue to plague private IT, right? And until we, I think, recognize those and take it upon ourselves to collaborate across these organizations and take a look at technology and innovation that's happening out in the industry, this is going to continue to persist, right? And that's where there really is a tremendous opportunity for, looking at technologies that were once really only available to those real mega service providers. So SDN's been around forever. It's been talked around for a long time. And the Amazons, the Googles, the Microsoft Azures, they actually acted on it, right? So they looked at this promise of what SDN can bring. They hired and staffed up huge R&D departments, and they developed their own proprietary implementations, right? And it was really to address a lot of these challenges we're seeing from a networking perspective, both in the campus as well as in the data center, that are driving IT complexity, security. How do you handle the phenomenon of bring your own device? How do you handle the notion of cloud today? How do you get more visibility of your network and the agility to configure your network in a much more dynamic and faster fashion? And that's the true opportunity that SDN brings to the table, along with a lot of the other open cloud initiatives that are happening that I'll cover next. All right, so, yes?
Why haven't we chose to keep up with the technology side of setting up the network? Why is it still so archaic?
Yeah, so the question is, why haven't we kept up? I'm saying it because I think I recorded it, but sure. I'll give you a book so that I could encourage good questions.
Thank you.
So why haven't we kept up from a networking perspective? I truly believe it's one of the hardest pieces to abstract and control from a central point, right? So if you look at servers, right, they're, by and large, they're not moving, right? It's one point and you're just sharing one given resource, right? One of the challenges of networking is there's so many touch points, right? Within even a network under one organization, and beyond that, you have to make that network work seamlessly with other networks, right? They've got to interconnect with no problem at all, right? And we've gotten to a point where the current model has worked. It has certainly been reliable and robust and secure, and everybody uses it all the time, right? But I think now is the time where we're starting to see that change of, okay, how can we automate it and make it even faster to deploy? So, all right, so I wanted to really cover the nuts and bolts of it, start basic, right? What is SDN, the definition of SDN? So if you go onto Wikipedia and look, right, if you look at traditional networking, right, because of its complexity, the control plane and the data plane were always in the same physical device. So when you configure, it's almost like configuring a traffic light, the routing protocol or directions of where traffic is directed or who can go where, right? That was always controlled right on that specific device, right? So as a result, from you configure a network or you add somebody new or if somebody comes online with their laptop, right? That visibility, if you want to do something specific for that end user or that new device, you have to go to every box and reconfigure that control plane. Now there's management software that's out there where you can store all these configs in one place. You can certainly push configurations device to device, but none of it's done on a full platform basis, right? So what SDN does is it takes that control plane, takes it out of the physical device itself so that it's now separated from the data plane. So the data plane now is just a data mover, right? So it still dives deep into a packet, looks at packet information, right, gets direction now from a control plane that's now housed on a central controller that pushes down, right, the instructions of where data needs to go, right? And as a result, you get an ability to look at all your devices, right, as if they were one logical resource. It gives you the ability to control the network from one single point. Does it make sense? Any questions? Comments? If you don't believe me, look it up on Wikipedia. But if this, that's a good definition I found. Okay, SDN is always often associated with cloud, and one big movement that you may have heard about as well is OpenStack. So, wanted to provide a definition for that as well, right? So, OpenStack is a means to control compute, storage, network, and virtualization technologies, through a single operating system, right, or a cloud operating system. So it's one thing, once you've automated that network, you've really provided a solid foundation now that you can control all those devices that you have in a single control plane, to now automate your entire data center as well, right? And build it into the context of what you're doing with compute and storage. And that's what OpenStack's all about. So again, this is technology that was certainly pioneered by these mega service providers, but now is becoming commercially available. So OpenStack is an open source project, just like Linux started, right? And what they do is they've developed different modules of code by a community to help the automation of each of these pieces, and then overlaid a self-service catalog, a self-service automation application on top of all of it, right? And it's a bunch of coding engineers, so they get creative in naming, right? So you got Nova, Swift, Glance, and these different components of it. And what you're seeing today is, now that this is becoming tested and hardened, right? Vendors are now taking and commercializing this. So just like you saw with the Linux industry, where, hey, it was pretty much a Windows world for servers, once those companies like Red Hat, SUSE, and I think they're now Novell, right, that came out and actually started to commercialize these and put an enterprise support infrastructure behind it and the right utilities and binaries to make this functional, Linux is now very predominant, especially with major service providers, as the operating system of choice, right, within an environment, right? So the same thing's happening there from a cloud perspective as well. Now, so a couple other things that does, right? So you might say, well, you know what, I do server virtualization today, and we automate a fair portion of the deployment of an application, so sometimes we call that our cloud, right? The reality of OpenStack and this movement of SDN, it's also driving another phenomenon within the data center, and that is this notion of scaling out, right, instead of just scaling up. So if you look at server virtualization at an enterprise level, how many have heard of pets versus cattle? So if you Google this, right, so there is a whole blog, a whole industry movement around software development around this notion of pets versus cattle. So the big difference between pets and cows, right, is a pet you name, right? So a pet you name, a pet you take care of, you don't kill your pets, and you can't swap pets with others, right? A cow serves a very specific purpose, right? So you don't name your cows, right? If you buy a cow and it's expired, well, you don't buy the cow, but if you buy meat and it's expired, right, you don't think twice about it. You swap it with another cow or some other thing, right? So that same phenomenon is happening within application development, right? So traditional applications are done in the pets model, right? So you still in a virtualized world, right, care about that virtual machine, right? And in many organizations, you name them, right? So this one's called Nova or Chardonnay or whatever, right? And then you care and feed it, right? You still worry about, okay, is that getting on the right server with enough memory and enough virtual CPUs to perform, right? Do I have the right storage area network behind it to meet its capacity needs, right? And if it fails, oh, it's my pet. I got to make sure it gets migrated, right, to the right disaster recovery location. And by the way, it's got to have the same bedding and the same doghouse and so on and so forth, right? So what they're doing now, and why another reason why public cloud is catching so much steam, is most of these retail applications, like for those of you looking at your smartphones now, right, or apps, if you click on these apps, there's a lot of individual components, right? And they're developed almost as infrastructure as code on a cattle model, if you will, right? Where that application is actually run across dispersed compute over physical devices that are everywhere, right? And the idea behind that, so Netflix, all these various major retail services that are provided now to consumers are really developed in that model. So if that server goes down, right, or that network connection needed for that application goes down, it instantaneously fails over onto another cow, right, or another cattle, or it might be run on many cattle, right? So that's the phenomenon that's happening, that's being enabled by this OpenStack or cloud infrastructure software layer that's becoming very prevalent in the industry. Right, so when we talk about programmability or programmable infrastructure, SDN and open cloud architectures are driving that phenomenon. Okay, so now that I think we have a baseline of what SDN is and what it means to cloud automation and also revolutionizing the way we configure networks, wanted to give you some glance into the standards as well as some recommended tips of how should I go about looking at implementing my SDN infrastructure, if you will. And the good news is all this development and all this innovation is now becoming mainstream in the form of standards and open source, right? So just to walk through some of this, right? There's open source SDN controllers, right? So that's being developed in Open Daylight, right? There's a whole community of people developing apps, if you will, specific to network automation as well as cloud automation, right? And all that code is published in an open environment, right? There's even Open vSwitch, which is a open virtual switch software project, right? Now, within SDN, right, it's not an SN, right, or not just a software network, it's a software-defined network. There's a very relevant hardware component to it as well, right? So in order for SDN to work, right, there needs to be standards at the hardware level so that the data plane can actually understand and communicate with that new control plane that's no longer on that device, right? So standards like VXLAN, OpFlex, the ability to automate different types of devices as well, in addition to switches for load balancing, for firewalls, for IPS, right, are being standardized. Other underlay protocols like NVRG and Geneve are being talked about as ways to kind of create an open environment, right, that can drive an ecosystem just as if you were managing an environment of multiple devices. The other one is programmability, right? So, for those of us that have been in the network industry a long time, we've probably done a fair amount of scripting, right? So instead of having to type in commands manually one at a time on a keyboard, you can run a script, right? Now, the challenge with that script is it only configured that one networking box. Scripts today, now in an SDN environment, can actually configure an entire environment, right? And if you actually adopt cloud operating systems, they can actually deploy an entire application through a script, right? Or through programming itself. Right, so I definitely encourage everyone to embrace and learn about the various open standards and source that are out there. The second recommendation regarding, I'm getting an echo up here. Really? Okay. Okay. The second recommendation when it comes to, wow, I'm definitely getting it. Let's stand right here. SDN is staying flexible, right? So, this isn't something that has to be cut over right away, right? So, look for products, look for architectures, come up with implementations where they can be easily migrated into this new infrastructure, right? So, there are products out there, there are devices out there that certainly can still run in their existing capabilities. So you can run a traditional 3-tier architecture. You can migrate to a lot of these new architectures that are being recommended, like Spine Leaf and CLOS, where they're trying to collapse the number of layers within a network and provide a high-performance infrastructure. It's not like you have to buy products or look for solutions that only fit into certain silos. And then ultimately, keep a platform that's going to allow you to have the widest variety of choice in terms of the SDN infrastructure or the cloud infrastructure you want to adopt, right? Look at the open applications you want to adopt. Think about, is this a platform I want to integrate both my physical and virtual infrastructure? And is this going to give me the most freedom of choice in terms of the applications and usages that I have in the future? Another recommendation is, embrace change and learning, right? So, one thing that is a constant within IT, it is always changing, right? So, SDN and cloud, I think, are driving a tremendous amount of technology that is driving a lot of tremendous new thinking, right? So, it's interesting. I was looking at job postings the other day, and not that I'm looking for a job, but it was just interesting to see that programming is now a requirement in many engineering jobs for a network administrator, right? So, it's something that I never saw before, right? And then also the years of experience that they need for a network provider have gone down tremendously, right? So, it's really interesting. So that's one. This whole DevOps model is another buzzword you may have heard, right? It's really changing the way IT works across those silos. And the one thing with DevOps, it's the it's the integration, if you will, or the Venn diagram of development integrating with operations, right? So what you see is it's a cross section of all of it, right? So all these technologies that I'm talking about, the fundamental technologies don't change, right? A VXLAN, as you dig into it, looks a lot like a VLAN. It allows you to stretch layer 2 over a layer 3 fabric, but ultimately it's still about, okay, VLANs, policies for security. QoS is still dealing with queues and DSCP and strict priority queues. But from a DevOps perspective, it's how do I take that knowledge that I knew and could configure for one box and make it something that's consumable by other organizations and other silos that I work with within my IT group, right? So really think beyond just what you manage day to day and how to embrace that change. Another quick one I'll talk about is, bimodal IT is being talked about a lot, right? So the method of development used to be extremely slow, right? You would prototype something, you would pilot it, you would test it, you would run it in its own safe environment before ever deploying it. Because of these new development models, because of the pets versus cattle programming model, there's people that can launch extremely fast now, right? Because they don't have a fear of hardware going down or hardware changing, right? They're able to deploy much quicker. So a lot of organizations are driving this bimodal model of development where they have 2 tracks of development or software development to speed up the process of their innovation. And last but not least, it's hard to say from a networking perspective, but really look at innovating at a systems and platform level, right? So, I've been in networking since about '95, right? And it used to be about talking speeds and fees and the protocol wars, right? So Ethernet wasn't even, it wasn't even determined that Ethernet would be the winner from a networking perspective. So for a couple other books, what were some competing protocols against Ethernet? I can't pick someone from Cisco. Go ahead. DECnet, okay, that's a good one. That wasn't one I was thinking of. Well, I think we're either dating ourselves or people are getting tired. Any others?
What's the question?
Competing technologies to Ethernet. Before Ethernet was established as kind of the predominant networking protocol on layer 1, layer 2 technology.
How about Apple Talk?
Apple Talk? Yeah, we'll give that to you. That's you have one or? Okay.
What, token ring?
Token ring's a good one. That's a good one.
IDX, SPX.
Okay, we'll give you that. That's a layer 3 protocol, but that's good. Okay. Anybody used FDDI?
Oh, yeah.
Yeah. What about VG Anyland? 100 VG? No? Okay. Anyways, I worked at HP in the day, and we got squashed by Ethernet when that happened. But okay, so got to move along here. So I'd encourage to challenge your supplier to innovate at a platform level, right? So it's not about just the controller piece. it's not about just hardware, is how can I develop an entire system and innovate at a system level to drive a real business outcome and value to me in terms of provisioning, not just the network, but across the entire data center itself per se, right? Or how can I automate my network to drive actual value in the business? So wanted to bring up an example of the danger of how SDN can be used incorrectly, right? So I've got 3 kids. They're 5, 8, and 11. The 2 oldest ones are daughters. My brother bought my oldest daughter at the time, this was probably when she was about 7, a Kindle Fire when it first came out, right? And the idea behind it, it was for reading and her to embrace reading and learning, right? And lo and behold, she downloads, turns out this thing can do everything, right? Because it's got internet access, it can run games. She downloads this game, and I call it the Pink Pony, but it's actually My Little Pony, right? So I'm like, okay, it's harmless, go for it, right? She's on it all the time, right? Just very fascinated by it. We're trying to get her to read books when she's playing this darn game, right? And it turns out there's a lot you can do with this game, right? You can actually mine and earn sapphires. So there's this form of virtual currency on this game, right? You can create your own equestrian park and join buddies in terms of equestrian shows. You can stream movies and videos, right? And one day I noticed there was a tremendous amount of charges on my credit card that were coming from just some random place, right? And it turns out she was actually purchasing these sapphires, right, to buy other ponies to compete in shows or what have you. But I guess for me, it really resonated that, really beware of running, innovating in a vacuum, if you will, right? So you really have to think at a system level. So for her, it was just this game, right? The other thing that she used to do frequently was actually bring my ability to work at home down, because she's driving so much bandwidth from these games, and I live in the sticks and Loomis, and I don't get any bandwidth, right? So it's like, I'll be on a telepresence, the thing will be all choppy, and the reality is, she's hogging most of my bandwidth because she's running this game, right? And I didn't have the ability to control or QoS and so on and so forth at my house. So the lesson is think big picture, right? Don't let the virtualization guys run networking just on their own, right? Work with them. Let's figure out how we can make sure that the software side of networking or software virtualization actually ties into our physical infrastructure and works all together, right? So, so beware of the pink pony. I'd be remiss if I didn't advertise a little bit about the solutions of Cisco, right? So, from a Cisco perspective, we're attacking it in various ways, right? One is from a solution perspective for the data center. So we've developed something called ACI, or Application-Centric Infrastructure, which is a continuation of our Nexus product line that really fully embraces SDN comprehensively as a system to incorporate virtual networking, your physical infrastructure, and the control of all of it in a seamless fashion. So, we've got a demo running downstairs. I'd encourage you guys to stop by if you have a chance. The other thing we have is an APIC EM, which is Application Enterprise Module. So this is the campus version of SDN. So the use cases in a campus are very different, right? You're not worried about multi-tenancy or deploying applications in a streamlined and a fast fashion. APIC EM actually allows you to very seamlessly roll out, say, quality of service or security methods in a very quick fashion across not only infrastructure that supports OpenFlow and new SDN standards of the future, but on your existing iOS equipment today. So we wanted to really make sure we took into account investment protection. The other key piece of this is to us, because it's basically the control plane, it's actually included in our products. It's not something that's purchased separately. It's software that runs as a virtual machine or on software, a set of server appliances that basically becomes the control plane of your entire network. One quick use case model of that, or a couple of them, is security automation, quality of service provisioning, and ION optimization. I'll walk through the security model in the interest of time. So imagine, right, we've got all these fancy appliances for security, right? You can find, malware files down to an individual PC or smartphone or tablet. But once you find it, right, it's very hard. Most organizations can't react fast enough to actually quarantine that device, right? With an SDN controller, we actually now have the ability to integrate control with security services, such that when you find something that's wrong in your network, you can actually act immediately to quarantine that incident from the rest of your network. And even do it in an intelligent fashion that, hey, let's just put them in the guest internet access portal and not let them have access to our enterprise assets, right? So that's one use case of what SDN can provide. We've certainly had to drink our own champagne at Cisco as well. So one of the things we did was actually adopted SDN in the form of SDN for our data center. Haven't really done it on a campus-wide basis yet, but we used OpenStack, and we really took a hard look at, okay, are we competing against those mega service provider clouds out there? The good news is we found after adopting it and actually being hard on ourselves and measuring ourselves was actually driving tremendous value across time to deployment, cost of equipment, both from an OpEx and CapEx perspective, and just the quality of the service itself. It's kind of interesting. I was told our IT department actually doesn't get a fixed budget. They've got a blank check, right? Yet, year over year, we've been declining at about 5%, even though Cisco as a company has been growing, right? And we're starting to offer cloud products and services. So a lot of it is from reinventing ourselves. And they've also had to reorganize. That was the other interesting epiphany that Cisco IT came to as well. Okay, so I'd like to close with an analogy to the pink pony, right? So, talked about the danger of running, say, a software networking only and maybe not thinking about how that integrates as a system or what the rest of the hardware. So what I did was, I embraced change and learning, right? I got rid of my Linksys home router. I got the mothballs out of my wallet, and I went out and bought a Meraki security appliance, right? It's a full-fledged firewall, and it's a gateway as well, so it's my home router. I bought some Meraki APs also. It's cloud-managed software, so this is actually a management application that you see that's run off a web portal, and I wish I had a bigger monitor and screen, but I have complete control of my network now. I have complete visibility. I'm able to set quality of service across a wide variety of factors. Do I have a laser pointer here? So as you can see, God, I can't even see it because it's so blurry, but it's like, this is actually a listing of applications. So if you can see here, ESPN is number 5, right? YouTube ranks up here in my house. I'm not keeping up with maybe the industry trends, but I've got like 9 devices for my whole household, so there's 5 of us. So, people are talking about 3 per person now. I'm not really there yet. I can track exact operating systems within my environment. I've got a mobile device management, which is actually free of charge on Meraki. So if my kids are in for a rude awakening, I can actually click into a device, see what apps are downloaded, see how much storage they're using on that device. I can actually delete applications. I can wipe the whole device. I can require a password on it. I can actually locate where they are. So this is me embracing technology, right? And just not being comfortable with the status quo. And what has happened is, my daughter, thank goodness, doesn't do the pink pony stuff anymore, and she's a lot older now. So, her newest fad is watching Shark Tank. So, when she watches Shark Tank and is streaming, video at 1.5 meg, I now actually control quality of service. So if I'm at home, my laptop actually always gets the highest bandwidth, and she can deal with watching Mark Cuban in a choppy fashion. And then the other thing that she's gotten started on is we got her into 4-H, and instead of virtual ponies now, she's doing the real thing, right? So we've had 3 sheep this season, but she's showing sheep, and the unfortunate part is she's naming them. So we're not selling any of them. It sounds like it. But they're great lawnmowers, and they're helping from that perspective. So I'm a little over time, but just wanted to tie kind of a fun consumer example of how technology comes to play. And thank everyone for their time. I know we have a few minutes before the other one starts. If you have any questions, I'll be here, and I've got a few books left as well. So if you'd like a SDN dummy book, please come up, and be happy to meet you. So, thank you.